right, section 2.2, graphing polynomial functions. We need to be able to know whether or not a function is a polynomial. We need to be able to identify degree, leading term, leading coefficient, and the constant term of a polynomial, because all of those numbers have significance in helping us understand the graph. We need to determine whether zeros exist based on a theorem known as the intermediate value theorem. It's not as scary as it sounds. In fact, most students make the intermediate value theorem a lot harder than it needs to be. It's just a verification of a zero. It's not actually finding the zero. We're going to learn about zeros and their multiplicities. So we already talked briefly about zeros in chapter 1. Zeros are the solutions or the x-intercepts. They come from the factors. And based on the multiplicity, we can tell how the zeros are going to act on the x-axis. So if they cross through the x-axis, how are they going to act at that point? Based on the multiplicity. If the multiplicity is odd, it's going to cross through, and if the multiplicity is even, it's going to bounce like a parabola on that point. Okay, we're going to talk about the end behavior of a polynomial function. That's like whether the ends go to positive infinity or negative infinity in the y direction as we move from negative infinity to positive infinity in the x direction across the graph. We're going to use all of this stuff to graph and solve some application problems. Okay, so a polynomial function is a function of this form right here, where we have a coefficient, a variable with an exponent, plus or minus a coefficient, and a variable with an exponent, plus or minus more coefficients with variables with exponents, till we get all the way down to our variable with no exponent and then no variable at all, right? So all of our coefficients have to be real numbers. The leading one, the leading coefficient can't be 0, or that pretty much eliminates this leading term, and this becomes the leading term because the leading term can't have a coefficient of 0, or it just doesn't exist. And then n, so n is the exponents. N is a non-negative integer. I guess a better way of saying that is positive integers. But the reason it says non-negative integer instead of positive integers is that technically the last one on the end here, I don't think that should be a 0 on the end. I think it should be some sort of constant value instead of a 0, but that's all right. I don't know. I want to check that typo now. I'm going to make a note to myself. Is this a typo? Big question mark. Okay. So x to the 0 power would follow this same pattern of we've got an nth power, n minus 1. So like say this was the 7th power. This would be 6th power. And then we'd have a 5th power, 4th power, 3rd power, 2nd power, 1st power, 0th power. So that's why we say non-negative integer instead of just a positive integer, because technically 0 is not negative or positive. And that is included as a possible exponent. We just don't write it. Okay, the domain of a polynomial function is always all real numbers, so from negative infinity to positive infinity. We're going to go through these 6 questions and figure out if these are polynomials or not. So let's look at these rules. The coefficients have to be real numbers. That just means they're not imaginary. N has to be a positive integer whole number exponents on our variables, right? So looking at question 1, this coefficient is a square root of 2. Think about, is that a real number? And then pi, they threw in some really weird stuff in here. Is pi a real number? Are the exponents okay here? Do we have exponents that are just positive whole numbers or 0? So what do you think about number 1? Is number 1 going to be a polynomial or not? Oh, it doesn't? So my notes are wrong and yours... Okay, Dominic, what do my notes say? I must have grabbed a different one. Here, let me bring it again. So some of you may have different notes than others. Some of them are apparently correct and some are not, depending on what year I copied them. So this plus 0 that was at the end of my notes should be an a sub 0, and it's just indicating the constant term at the end. All right, so this one is in fact, yes, a polynomial function. Sometimes the square root and the pi throw people off, but square root of 2 and pi are both real numbers. So there is nothing wrong with calling this problem a polynomial function. Oh, real numbers, not real problems. I can't speak and write something different at the same time. Real numbers, not imaginary. Okay, let's look at number 2. Number 2, yes or no? So if you said no on question 2, you are correct. And the reason that's correct is technically because x is in the square root, that would mean that x has an exponent of 1/2. And that 1/2 is not an integer. Not integer. So that's why that one's no. All right, let's look at number 3, yes or no? So number 3 is yes, and that is because even though the exponent, see on problem 2, the exponent couldn't be 1/2 because it had to be an integer. But the coefficients can be anything as long as they're real numbers. So 1/2 is a real number. It's just the way it's written in the original problem, it makes you stop to think. So if you rewrite that coefficient as a 1/2 instead of x squared divided by 2, that means the same thing. Okay, number 4. All right, I'll go ahead and tell you this one is no, because x is not a positive whole number exponent, right? X is a variable. We don't know what it is. So if it's a variable, it's not, it doesn't fit the definition of n here as a non-negative integer. Not a positive integer because it's a variable. Okay, go ahead and start looking at number 5. In fact, we will learn about these in chapter 4. This one's called an exponential function, and an exponential function is not polynomial. Number 5, hopefully you've had a chance to think about it, is no. So yeah, so on number 4, since x is a variable, that number is going to change. Remember, this is a function. We're plugging in a number for x, we're getting out a value for y. It can't be a polynomial if that exponent's going to keep changing. It has to be a defined value. Exactly. Okay, so back to number 5. Number 5 is no. If you want to understand this a little better, when it's in the denominator like this, we could rewrite that as a negative exponent. So this is not a positive integer. It's a negative integer, so it's not a polynomial. Number 6. Just to kind of finish this up, because this video is starting to be too long, I'm going to go for it. But yes, thank you, Dominic, for giving me an answer here. Yes, this one is a polynomial function because it's okay to just have a constant. That just means the degree, the highest exponent, is 0. Okay,